Hello everyone, so welcome back to my new video. So myself, I'm Santosh Morar, currently pursuing my fifth sem engineering in Sri Venkateshwara College. So today I'm back with a new topic in the digital communication. So let us dive into the topic. So the topic is modulation techniques in digital TV broadcasting. So the introduction. In digital TV broadcasting has revolutionized the way of we consume visual content, offering unparalleled picture quality, immersive audio, and interactive services. At the heart of these technologies advancements lies modulation techniques, which enable efficient transmission of digital signals over various media. This analysis explores the modulation techniques employed in digital TV broadcasting, their benefits and limitations. So to know about the techniques of used in TV broadcasting, we should know about modulation. So modulation is the process of varying a high frequency carrier signal to encode information from low frequency message signal, enabling efficient transmission over communication channels. So these type of modulation include different types of modulation. So modulation is a crucial in radio broadcasting, telecommunication, wireless networks, satellite communication, and radar system, allowing for efficient bandwidth use. So improved signal to noise ratio and increased transmission distance. Also, various modulation techniques include analog and digital methods facilitate reliable transmission in modern communication systems. So the types of modulations are analog modulation, digital modulation, and pulse modulations. In analog modulation, there are three different types. Those are amplitude modulation, frequency modulation, and phase modulation. In digital modulation, we have amplitude shift keying, frequency shift keying, and phase shift keying, and finally quadrature amplitude modulation. And then finally, in pulse modulation, we have pulse width modulation, pulse position modulation, and pulse code modulation. And then if it comes to amplitude modulation is a type of analog modulation where the amplitude of high frequency carrier signal is varied in proportion to the instantaneous values of the low frequency message signal. So this process allows information to be transmitted efficiently over communication channels, and it is commonly used in radio broadcasting, telephone systems, and simple communication system. And then frequency modulation. So frequency modulation is type of analog modulation where the frequency of high frequency carrier signal is varied in proportion to the instantaneous values of low frequency message signal, providing resistance to noise and interference, and is commonly used in FM radio and radar systems, so etc. And then phase modulation. Phase modulation is a type of analog modulation where the phase of the high frequency carrier signal is varied in proportion to the instantaneous values of low frequency message signal. So FM is commonly used in satellite communication, wireless communication, and radar systems, and complex implementation and higher bandwidth. And then it comes to quadrature amplitude modulation, QAM. So it is a type of digital modulation that combines two amplitude modulator signals, one in phase and encode data. So QAM varies both the amplitude and phase of the carrier signal to transmit multiple bits of information per symbol, increasing data transmission rates and efficiency. So this modulation techniques is widely used in high-speed communication systems such as wireless networks, digital televisions, and resistance to noise. And then orthogonal frequency division multiplexing. So it is a digital modulation technique that divides high-speed data stream into a multiple slower streams, transmitting them simultaneously over the multiple orthogonal frequencies. So this allows for efficient use of bandwidth, resistance to interference, and reduced signal distortion. So OFDM assigns to data subcarriers spaced evenly apart, so enabling multiple signals to share the same frequency band without interference, widely used in wireless standards such as Wi-Fi, 4G or 5G, and digital broadcasting. And then OFDM optimizes data transmission rates, capacity, and reliability. And then if you compare digital versus analog modulation, so digital modulation and analog modulation differs in how information is transmitted. Okay, so analog modulation is transmits information as continuous waves varying amplitude, frequency, or phase examples AM, FM, or PM. In digital modulation, transmits information as discrete digital signal using binary codes, zeros and ones. Example, ASK, FSK, and PSK. And the key differences are in digital, higher bandwidth efficiency, resistance to noise, and scalability. But in analog, simple implementation, low equipment cost, and ease of demodulation. So, digital modulation is used in modern communication systems, while analog modulation remains legacy applications such as radio broadcasting. And then challenges in modulation. So noise and interference, which distorts signals and reduce quality. And then you have bandwidth limitation restricting data transmission rates, and frequency distortion causing signal degradation. And then we have multiple interference resulting from signal reflection, and we have non-linear effects causing signal distortions. So these are the challenges faced in the modulation. And then finally, future of modulation techniques. So higher speeds, faster data rates through advanced modulation schemes, increased efficiency, better spectrum efficiency, and reduced power consumption, and improved reliability, enhanced error correction, and adaptive modulation. And then integration, convergence of wireless and wired technology. And finally, emerging applications, IoT, 5G or 6G, quantum communications, and satellite networks. And the advancement includes OTFS, NOMA, QKD, and AI optimized, and MM wave, and THZ modulation. And then finally, conclusion. So, modulation techniques are crucial for delivering high quality digital TV broadcasting services, offering improved spectrum efficiency, signal quality, and transmission capacity. Advanced modulation schemes like OFDM and QAM enable high definition resolutions. So, multi channel transmission and robust receptions. As broadcasting technology evolves, modulation techniques will remain essential for innovative services and enhanced view experience. So this is about the topic. Thank you for watching the video. Thank you.